Okay, good morning, Cappuccino. Here we are again. It's time for some notes. You did an investigation on arithmetic and geometric series and hopefully came up with the formulas that the investigation stepped you through. But in case you didn't, here they are. Here is the formula for the sum of n terms of an arithmetic sequence. And these are all the formulas I'm about to show you are all right here in the formula packet under Topic 1, Algebra. So we'll come back to this in a minute. But here we go, let's go over this. So if I have an arithmetic sequence, in other words, a sequence that is created by adding a common difference to each term in the sequence, I can find the sum of those, the sum of all those numbers, by taking how many numbers I have divided by 2 times the first term plus the last term. So you did this in the investigation with Gauss, who was adding 1 through 100, and you saw that it made pairs. You had the first term plus the last term equals the same thing as the second term plus the second to last term. Okay, so we end up with this lovely little formula. So let's go ahead and give it a try. Find the sum of the sequence, and I've got a sequence here. Let's go ahead and identify the different variables. By the way, in math space, you're going to have problems like this. And when they refer to A is the same thing as U sub 1. A is the first term, okay? So if I look at this, I need to know N, which is how many terms. So N would be 1, 2, 3, 4, 5. I have 5 terms. I need to know U sub 1. U sub 1 is the first term. That's also A in math space, okay? So that would be 2 is my first term. And U sub N is the last term that I want to be adding together. So the last term is 102. Okay, so now we can go ahead and solve this. So the sum of 5 terms, so n is 5, is equal to 5 over 2 times 2 plus 102. So I wanted to do one that had an odd number because when we did the Gauss problem, we added the first and the last term. 2 plus 102 is 104, and 27 plus 77 would also be 104. But then this one doesn't have a pair, but guess what? It doesn't matter. It still works. Okay, so the formula still works. Basically, you could just add this to itself, and you'd get 104, right? 52 plus 52 is also 104. All right, so we're going to go ahead and grab our handy-dandy calculator, and we're going to do, I'm going to do parentheses first, like I'm doing it by hand. 102 is 104 times 5 and divided by 2. And I get my answer of 260. Okay, so in case you're, like, really, does that really work? Let's go ahead and check it. Since this is a nice short sequence, short sequence, I can just add them. 2 plus 27 plus 52 plus 77 plus 102. And what did I do? I made a typo. Let's do that again. 2 plus 27 plus 52 plus 77 plus 102. And I get 260 as well. Okay, so there is using that formula. Okay, let's get a little bit trickier. I think I'm going to turn the page so I have plenty of room. Yeah, I need more room for my next example. So let's do one that's a little bit harder. So for my next example, find the sum of the first 10 terms of the sequence with u sub 1 equal to -5, and yes, we can have negatives, and d equal to 8. Okay, so if this was math space, if this was a math space problem, u sub 1 would be a. So math space would say a, okay? So this would be, if it was in math space, and you are going to have a problem like this in math space, it would say a equals -5. And remember, in math space, a is u sub 1. Okay, so let's go ahead and see if we can figure this out. We know that the sum of n terms is equal to n over 2 times u sub 1 plus u sub n. So let's see what we've got here. we need to find the first 10 terms. So we know that n is equal to 10, and we have u sub 1, but we do not have u sub n. Instead, we know the common difference, but we don't know the 10th term. Okay, so we need to find the 10th term. How do we find the 10th term? That's where we need our formulas from our formula packet. Bam! I want to find the nth term of an arithmetic sequence. I need this formula right here. Okay, so in order to find that u sub n, I'm going to have to use another formula. So u sub n is equal to u sub 1 plus n minus 1 times the common difference. Okay, so can we solve for that? It's going to be 10. The 10th term is what I'm looking for. The first term is negative 5. And my n, again, is 10, because I'm looking for 10 terms, minus 1. And my common difference, they gave it to me. It's 8. My common difference is 8. Okay, so I can simplify that, and I get u sub 10 is equal to, if I stick that into my handy-dandy calculator, I get 67. Okay, so now I can go back and figure out my sum of my sequence. So the sum of the first 10 terms is going to be equal to 10 over 2. The first term, we already knew that, was negative 5. And the last term is 67. And so I can simplify that, and I get, if I put that into my calculator, I get 310. Okay, so in the formula packet, though, I want to point out that there is another formula for the sum of an arithmetic sequence. So this is the one we were just using. So it has the first term plus the last term times the number of terms divided by 2. But notice this one. What the heck is this? Notice what is different about this one than this one. This has a d, and it doesn't have a u sub n. Okay, it's got n, this one has n, it's got n a couple places. It has u sub 1, this one has u sub 1, but this one has the common difference. So we could have actually used this formula to solve this problem, rather than using two formulas. So where does this formula come from then? Well, it comes from just combining these two formulas together, like I started to do here. So let's go ahead and write down that. So the other formula that we have in our packet comes from combining these two formulas. Okay, so another formula. Let's go ahead and find it ourselves. So we have S sub n, the sum of the sequence, is equal to n over 2 times u sub 1 plus u sub n. And we know that u sub n is equal to u sub 1 plus n minus 1 times d. So where my u sub n is over here, I can substitute in all of this. U sub n, this is u sub n. I'm going to just put this in over here. So if I rewrite this, I get S sub n, the sum of the series, is equal to n over 2 times u sub 1 plus, but instead of putting in u sub n here, I'm going to put in all of this. So u sub 1 plus n minus 1 times d. And then notice I can combine my like terms, and when we do that, we get the formula that's in the packet. So the formula that's in the packet will be the sum of n terms is equal to n over 2 times this plus this would give me 2 u sub 1s plus n minus 1 times d. Bam. That is the other form of the formula for the sum of an arithmetic sequence if you don't know the last term. Okay? So if you do know the last term, this formula is super easy. But if you don't know the last term, we've got an alternative here for you. Okay, so let's now look at the geometric. The sum of geometric sequences, so a geometric series. So let's see, how am I going to write this down? The sum, okay, so geometric. series. The sum of n terms of a finite, and I'll get back to what that means in a minute, geometric sequence it ends up being this. S sub n is equal to u sub 1 times r to the nth minus 1 divided by r minus 1. And r cannot be equal to 1, and it also can't be equal to 0 or 0. Okay, can't be 1 or 0. If you had r was equal to 1, you'd just be multiplying by 1 every time. And so, like, if you started with 2, your sequence would be 2, 2, 2, 2, 2, 2. And if you're multiplying by 0, well, you're going to run out real quick. Start with 2, multiply by 0, you get 0. So 2, 0, 0, 0, 0, 0. Okay, so that's no point in having r be equal to 1 or 0. All right. This formula can be written another way. You'll notice here in the packet, that's the way that I wrote it. Or you can switch the difference here. You can switch it. And the reason why we do that is if r is a fraction, you would end up having a negative here, and we don't really like dealing with negatives, so we switch it and we just turn it like this. Okay, so, or if, oops, my Zoom meeting is about to start. I better hurry up and finish. Okay, or if r is a fraction, in other words, r is between -1 and 1, and remember, it can't be 1, so I don't put the little equal parts. If it's in between -1 and 1, you can use this one. S sub n is equal to u sub 1 minus r to the nth over 1 minus r. Okay, that way you avoid negatives. All right, let's do an example. Consider this series. (3 plus 15 plus 75 plus ... Okay, find the sum of the first 10 terms. Okay, so notice the formula. It's actually kind of a little bit simpler than the arithmetic one. We don't need to know the last term. Okay, all we need to know is we need to know how many terms there are. That's n. We need to know the first term. That's u sub 1. And we need to know the common ratio. So perhaps the common ratio might be the trickiest thing to figure out. But the common ratio, you're just asking yourself, if I have, let's write this as just a, to write it as a sequence, we remove the plus sign. So here's the sequence. Here's the sequence, comma, ... So I'm multiplying by some number. This one's really easy to figure out. You can just see that it's 5. 3 times 5 is 15. 15 times 5 is 75. But if it wasn't so obvious, you can just take the second term, divide it by the first term, and you will get the common ratio. So 15 divided by 3 is 5. So our r is equal to 5. So now I think we have everything we need, right? So we have the common ratio. The 3 here is my u sub 1. My n is going to be 10, and now we're good to go. So the sum of 10 terms is going to be equal to u sub 1 is 3, 1 minus r is 5, to the nth, n is 10. Oh, I'm using the one for fractions. Oops, stop. Sorry. I mean, I could, doesn't matter. I could use either one. You're going to get the same answer either way, but let's go ahead and use the one that's meant for whole numbers. Okay, so where was I again? 5 to the 10th minus 1 over 5 minus 1. And I just realized when I was doing these notes that I meant to go over the investigation where we discovered this, but I'll do that next week. Okay, when we talk about, we're going to talk about infinite series next week. You did an investigation on infinite series, but we'll talk about those next week. Right now we'll just do finite series. Oh, so I forgot to talk about, what does finite mean? Finite means it ends. doesn't go on forever. So we know how many terms are in the series. It's not an infinite number, it's a finite number, like 10. There are 10 terms, or there's 20 terms, or there's 102 terms, or there's 1,000,005 terms. But it does end. It doesn't go on forever. Okay, so we'll talk about ones that are infinite next week. All right, so let's go ahead and put this into our handy-dandy calculator. So 3 parentheses 5 to the 10th minus 1. I'm going to go ahead and do my numerator first. And then 5 minus 1 is 4, so divide that by 4. And I get this really huge number. So yes, geometric progressions get big really fast. So when you add them together, you get really big sums really fast. 7,324,218. All right, now let's do a challenging one. Okay, that one was pretty simple. Let's go ahead and try a challenging one. So for our next example, consider the series. (5 minus 20 plus 80 minus ... minus, oh my gosh, I didn't leave myself enough room. I'm going to try and squeeze this in. 20,971,520. I didn't leave myself enough room. Okay, there is my series. And then there's going to be two parts to this. Part A, solve for n. Solve for n. Okay, how many terms are there? All right. So in order to do this, we are not going to use the series equation. Instead, we're going to find the nth term of the geometric sequence, because we know the last term. We know the first term. We can figure out the common ratio, so that all we have to do is solve for n. Okay, so we are going to be using this formula. U sub n is equal to u sub 1 times r to the n minus 1, because we need to figure out what n is. And we can't do that with the sum of the series, because we don't have enough information on that. Okay, we can't use this formula because we don't know that, we don't know n, too many unknowns. But this one we can use because we have enough information. So u sub n, that would be this one. Actually, you know what? We could find, yeah, we need to use that one. All right, so our u sub n is going to be here. That's our u sub n. Our u sub 1, of course, is the 5. So what do we need to find? We need to find the common ratio. All right, so r is equal to the second term divided by the first term. So that would be, notice a series is always addition. So if I rewrite this as addition, that would be negative 20. So the second term is negative 20 divided by 5, the first term, which gives me negative 4. So my r is equal to negative 4. Okay, so u sub n is this one here. And again, if I rewrite it as a sum, that's a negative. So negative 20971,520 is equal to 5 times negative 4 to the n minus 1. Okay, so now I am going to try and solve this. So first thing, I'm going to divide both sides of my equation by 5. So when I do that, I get negative 4194304 is equal to negative 4 to the n minus 1. And now I'm going to take the logarithm of both sides. When I have my exponent in the exponent, the way to get that down is to change this to a logarithm. So I'm going to take the logarithm of both sides. Now, we have a little issue here in that you cannot take the log of a negative number. So I'm just going to ignore the negatives right now, because the fact that this is negative really doesn't matter, because if we're timesing by negative 4, the only thing that that's doing is just flip-flopping the signs. So if r had been positive 4, if we had just multiplied by 4, we still would have gotten this number. It just would have been positive. So I'm going to ignore these negatives because I cannot take the logarithm of a negative number. So I'm going to ignore the negatives ignore the negatives, and take logs of both sides. Okay, because we can get this number if they were all positives, or the fact that they're flip-flopping negatives. It really doesn't matter. This is still going to be the same term number. The n is still going to be the same. So I'm going to rewrite this as 4194304 is equal to 4 to the n minus 1. Now I'm going to take the log of both sides, because if you do something on one side of an equation, as long as you do it to the other side, you're all good. Now I'm going to use my power rule. I'm going to bring that n minus 1 down front. And my Zoom meeting is supposed to be starting right now. Eek. 4194304. I'm now going to get my logs to one side. So my n is by itself, n minus 1 is equal to log of 4194304 divided by log of 4. And then magic happens. Put this into my calculator, and it equals 11. Okay, if you enter this in, you get 11. It's n minus 1. So then add 1 to both sides, and you get n equals 12. Holy cow. So we found n. Okay, so then once I have n, then my next question is find the sum. Find the sum of the series. Okay, we know it's a geometric series, so we need to use the formula S sub n, in this case is 12, is equal to, where's my formula again, is equal to u sub 1, u sub 1 is 5, times r to the n. Now we're going to go back to our negative 4. That's important. We're going to go back to negative 4 to the 12th minus 1, all divided by r, which is negative 4, minus 1. Okay, and if we stick that into our handy-dandy calculator, and you should check, make sure you can get it into your calculator, you end up with the sum of negative 16,777,215. So make sure that you can enter that into your calculator successfully to get this number. And then go and try the math space assignment, because you have problems just like this on math space. All right, good luck. Have a nice day. Bye-bye.